With a variety of remote sensing, geophysical, and in-situ sensors, the Jupiter Icy Moons Explorer or JUICE, of the European Space Agency, will conduct in-depth observations of the giant gas planet and its three sizable oceanic moons, Ganymede, Callisto, and Europa. In addition to thoroughly exploring Jupiter's complex atmosphere, the mission will investigate these moons as both planetary objects and potential homes. It will also examine the larger Jupiter system as an example of gas giants seen throughout the universe. Welcome back to my channel. Mission to Jupiter has been launched today, April 14, 2023. It is the JUICE spacecraft. Today we will uncover what JUICE mission will expect to achieve in the next decade. Jupiter Icy Moons Explorer, JUICE, was launched on April 14, 2023 by the European Space Agency, from Europe's spaceport in French Guiana, using an Ariane 5 rocket. JUICE will make use of 10 instruments and will be able to deploy an 85 square meters solar wings. Its mission is to investigate Jovian moon over a 35 flybys. Beginning in April 2023, the ESA's Jupiter Icy Moons Explorer will travel to Jupiter for 8 years. The project will look if habitable planets can develop around gas giants, and how the Jupiter system functions as a model for the many giant planets that are already known to orbit other stars. In order to put JUICE on course for its rendezvous with the Jovian system in July 2031, it will make a series of flybys of Earth, the Earth-Moon system, and Venus. Throughout its voyage, JUICE will pass past Earth 3 times, once in August 2024 to observe the Earth-Moon system, once in September 2026, and once more in January 2029. JUICE will travel to Jupiter for a total of almost 8 years. Although it won't arrive at Jupiter until July 2031, it will start performing scientific research 6 months beforehand. JUICE will continue to orbit Jupiter for several months, performing 35 flybys of Europa, Ganymede, and Callisto before finally orbiting Ganymede. From Jupiter's tumultuous atmosphere to the alleged existence of liquid oceans on 3 of its planet-sized moons, JUICE will need to answer how does the solar system function, and what are the prerequisites for the creation of planets and the appearance of life. The Galilean moons are the 4 biggest moons orbiting Jupiter. Of these, Ganymede, Europa, and Callisto, aside from Io, which is not known to be a water world, are supposed to have seas of liquid water concealed beneath their icy crusts. How deep are these oceans, and how far below the surface do they begin? If so, how much of each type of water do they contain? JUICE will investigate the hidden ocean layers and icy crusts of the 3 water worlds, as well as the conditions that shape their surfaces and atmospheres. It will also show how what we can observe from above relates to the vast internal oceans that are believed to be below. Together, these moons have the capacity to store an enormous volume of water, up to 6 times the volume of the oceans on Earth. All 3 moons' surfaces differ from one another, showing a mixture of older, dark, deeply pitted parts and wider, but more recent, faintly grooved terrains. On some of these moons, there is proof of historical or ongoing geological activity. JUICE will investigate the moon's current levels of activity and investigate how active they may have been in the past, creating a thorough portrait of this dynamic trio. This portrait will include information about how their mass is distributed internally, how their interiors have changed over time, and whether they have experienced tectonics or icy volcanism. The largest moon in the solar system, larger than Pluto and Mercury, and the only one with an intrinsic magnetic field, Ganymede, will be the focus of JUICE's primary scientific investigation among the 3 moons. Only Mercury and Earth, both of which are planets and one of which supports life, are other solid bodies in the solar system that produce dipole fields like Ganymede. An excellent natural laboratory for researching the characteristics and nature of frozen worlds is Ganymede. JUICE's primary objective is to characterize this moon, but it will also use its observations of Europa and Callisto to compare all 3 of Jupiter's water worlds. The spacecraft, which will be the first ocean world orbiter ever, will measure Ganymede's rotation, gravity, shape, and interior structure as well as its magnetic field and composition. It will also use radar for penetrating its icy crust down to a depth of about 9 kilometers. To properly comprehend the activities occurring in the Moon's space environment, JUICE will also examine the water vapor and other chemicals in Ganymede's atmosphere. JUICE will show Ganymede's outer layers of its thin atmosphere, which is composed of hot, ionized matter, as well as comprehending how the Moon's environment interacts with Jupiter's magnetic field. One of JUICE's main goals is to determine whether the Jovian moons have the proper conditions for habitability. Could life have sprung up there somewhere? Do any of the Galilean moons contain the elements necessary for life? JUICE will examine if the conditions for life could have ever arisen by analyzing the hidden oceans, magnetism, heating processes, tidal effects, surface activities, cores and compositions, atmospheres, and space habitats of the Galilean moons. It will assist us in understanding these worlds as potential homes for life as well as planetary bodies. Biologically necessary and significant elements, such as carbon, oxygen, nitrogen, magnesium, and iron, will be sought after by JUICE's high-resolution mapping. Given their buried oceans, these moons represent particularly fascinating possibilities for life. Understanding how habitable they are will help us better grasp how habitable cold worlds generally are across the universe, with scientific ramifications that go far beyond the Jupiter system itself. Importantly, JUICE's second target, the larger Jupiter system, will provide additional information regarding the potential for habitability in other planetary systems with a comparable composition orbiting other stars. Beyond magnetism and radiation, JUICE will look at Jupiter's complex gravitational environment, the relationships and interactions between the orbital dynamics of the moons, and the tidal interactions between the moons and their parent planet. JUICE will examine how many facets of Jupiter's ecosystem interact with one another overall. Our increased understanding of Jupiter, including how particles are accelerated and the principles underlying other physical processes we observe, will help us learn more about the solar system as well as other planetary systems and cosmic objects. Understanding the formation and evolution of gas giant planets and their moons is one of JUICE's main goals. There are two crucial times to watch for after the Jupiter Icy Moons Explorer departs from its Ariane 5 rocket. The first words, or telemetry, that ground stations receive from a mission are known as acquisition of signal. The first ground station to receive communication from JUICE is anticipated to be ESA's New Norcia in Australia. Solar array deployment comes next. The enormous 85 square meter solar arrays on JUICE will unfold like a complicated origami box. A cutting-edge science payload on JUICE includes in-situ, geophysical, and remote sensing instruments. High-resolution images of Jupiter's clouds and the Moon's geological features will be captured by JUICE's camera, Janus. The Moons and Jupiter Imaging Spectrometer, MIGIS, will study the frozen Moon surface's ices and minerals as well as Jupiter's cloud structures and atmospheric components. The Sub-Millimeter Wave Instrument, SWI, will study the exospheres and surfaces of the frozen moons as well as the temperature structure, composition, and dynamics of Jupiter's atmosphere. In addition to studying the Jovian aurorae and the composition and structure of the planet's upper atmosphere, a UV imaging spectrograph, UVS, will characterize the composition and dynamics of the ice moons. In general, JUICE will make it possible to fully characterize Jupiter as a planet and a system. It will examine how planetary systems like Jupiter's function both within and outside the solar system. Thanks for watching.